the first power. I did not make any hand waves here. I explained every single transition, how beta to the first power stays, everything else goes away. It's not hand wavy thing. Any more questions? Yeah.
I guess just for my clarity, this d omega and this omega, like what is it saying from which frames? Like what the equation?
Bar is a frame of mirror, no bar is frame of non-mirror.
So this is saying like if you're just in the lab frame, you
lab frame? Lab frame? Which frame did you say?
The lab frame.
Lab frame, okay, I'm in the middle of this.
I'm in the lab frame. This equation is saying light that is incident and then reflected off of the moving,
exactly.
I see its frequency change.
Absolutely, that's called echolocation. Yep. It's done with sound to observe airplanes flying or submarines. What they do, swimming or no? What do submarines? Moving. They also no, they whatever.
They slow.
They set up a
All right, scaring us, whatever.
Yeah, well, they do also sing though.
All right, are we good? Are we good here? So this is absolutely consistent with calculus. It is as good as calculus. Either they both should die or they both stay. Okay, because it's classical calculus. So let me then write that d omega over omega is equal to -2 beta cosine theta. Make sense? Now I need, yeah, go.
So this is separate. So this, on one side we have a differential and on the other side we don't?
Not yet, yeah, we will. Beta is really small. Yeah, and that's a good question. I will answer it in a sec. Any more questions? Yeah, so on the left side we have differential. What about right side? What is differential on the right side? I also want to see differential on the right side. So in order to continue this model, I will now look at the following. Shell expands, right, really slowly. And I need to to decide about some small period of time that will help me to calculate change of omega with change of volume. Let me correlate those, right? How fast omega changes, how frequently omega changes after each bouncing, right? So how long does each bouncing take? Time of traveling from previous bouncing to this bouncing. Does that make super duper perfect sense? So if I say that d omega changed over this period of time, now I need to see how far will expand this shell. Makes perfect sense? You could ask me when it was bounding, it was this point or that point. That's again calculus. If this shell is super thin, this is like in partition, I count it as flat, right? Awesome. So let me see. This is different colors. Let me use different colors. This is radius. This is radius. Let me use big R because small r is reflected. Yeah. What is this angle?
Theta bar.
Theta. This is theta because it's normal, and this direction of incident ray. That is exactly theta, and this was x-axis. Make sense? So, how long is this segment? C dt. dt is an infinitesimal period of time. Make sense? Light travels across this box for not that long period of time. So hypotenuse, no, not hypotenuse, this long leg, long side of isosceles triangle CDT is equal to what? Since this triangle is isosceles, I can multiply r by cosine theta and multiply by 2. How does that sound? Amazing. Oh, here is cosine and there is dt. Amazing. D omega divided by omega is equal to negative. Let me write here 2 beta and substitute cosine from this equation to that equation. What is cosine from this equation? It is c dt divided by 2r. Sounds good? Isn't that amazing? Right answer is yes. Yeah. Okay. Yeah. So we can cancel this. Now, what is beta times c?
V.
Good. What is v times dt? Awesome. So we got something really cool. D omega over omega is equal to negative dr divided by r.
Times beta?
No. What is beta times c?
Oh.
V. What is v dt? Dr. No beta. No, good question. No beta. See now, this is our infinitesimal beta expressed in terms of infinitesimal change of r. What this is called, if I, for instance, did not expand it adiabatically, what if I just warmed up sphere and it expanded? Then what it is called? Coefficient of linear thermal expansion. How coefficient of linear thermal expansion is related to coefficient of volumetric thermal expansion?
Q.
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 Yeah, this divided by 3. So volume, is it clear? Let's say I forgot about it. Let me look at this as sphere. So then I could multiply this by 4 pi r squared and this by 4 pi r squared. I can also divide everything by 3 and divide denominator by 3. Is it clear? What is 4 pi r squared? Surface area multiplied by thickness. dr. Volume of shell, which is change of volume of sphere. Awesome. So we got that d omega over omega is equal to negative 1/3 dv. What about 4/3 pi r cube? Volume. No, I just reproved something that you proved long ago, like in first year, that linear expansion and volumetric expansion differ 3 times, not cube times. And you know why? Because if you have L naught times 1 plus alpha delta t cube, it is approximately equal to L naught 1 plus 3 times 1 squared times alpha delta t. The rest you could throw away, and you could see that if alpha is linear expansion and volumetric expansion is 3 times different. And so here you go. Didn't do one thing, I didn't put here cube. Awesome. Alright, so we got something really cute. In what sense? What we can do to this expression?
Integrate.
Yeah. So it will be omega, ln of omega to the power of. Okay, let's move this to the left side, multiply by 3, integrate, add logarithms, put powers in right places. Let's do adult thing. So,
Omega cubed v.
oh, that's adult. That's not baby. Yeah. Sounds good? So as volume is increasing, omega is, yeah. So if, for instance, initial volume corresponds to this graph, to this graph, and if this was omega, then this omega is slightly reduced and became omega prime, for instance. And so the whole graph will shift. Does that make sense? Let me see if I want to say here something smart. Nothing smart, unfortunately. Let me say something stupid. I'm looking for, oh, here we go, adiabatic expansion. So what is it? 7, 8. So we just figured out that omega cubed times volume is constant, and in your homework you will figure out that T cubed times volume equals constant. Those two are adiabatic invariants or adiabatic laws. What other law you can derive from these two? Yeah?
Omega over T is a constant.
All right. So you guys see that omega over T stays constant. That's really interesting thing. For instance, we will do it more seriously next time. But let me do corny statement. If you see where is maximum of initial distribution, and you follow what's happening to maximum of the new distribution, right? Because omega over T stays constant, then you could say that omega of maximum distribution and T are related this way. That was observed before people built theory. See, we did not yet build theory, Planck's theory of blackbody radiation. But observed people were measuring a lot about radiation. They were getting the spectra, they were getting where is maximum, and they observed that if you look at omega max and divide by T, then it stays constant. So for two different temperatures, you could calculate frequency that corresponds to maximum of each spectrum, and you get that. What if I want to express it in terms of lambda, because it was experimentally discovered, and experimentalists don't like omega, they like lambda, I don't know why. How would you rewrite this law? Yeah?
T lambda equals constant.
Exactly, T lambda equals B. B is constant and it is universal constant. And this is called Wien's law. I'm afraid to misspell Wien's name. Wilhelm Wien, Nobel Prize, 1911. Because this was one of key observations in finding shape of blackbody radiation. So their Nobel committee decided to award Nobel Prize to this. B is a fundamental constant. Today it is, I think it is exact today because it is in terms of Planck's constant speed of light. We will get it, we will calculate B next week for sure, definitely next week. But if you are curious what B is equal to, it is 2.89, unbelievable, 777, whatever else, times 10 to the negative 3 meters Kelvin. So this law was absolutely important experimental observation made by Wilhelm, and I have here is constant. Yeah, this has exact value. When we will calculate what Wien's constant is in terms of sigma, Planck's constant, speed of light, we will see that all these parameters several years as they are defined as universal constant. You guys know that speed of light is universal constant, exactly defined. Right? Good. So Wien's constant is only expressed in terms of fundamental constants. We will do it next week, and that is a big deal. Questions? I will not make sure that I move my next, do my next. So next, I can make announcement. Next thing, I would like to approach closer to the behavior of this curve. So far, I will not calculate what it is. I will do this calculation most likely, not most likely, definitely on Thursday. And we will get this catastrophe on Thursday. Since things are going fast, most likely we will even approach Planck's idea. Let's see, fingers are crossed. Yeah, but because I'm going to explore further this curve, make sure that everything on the board is super duper. Awesome. Everything on the board is super and also duper, then I can erase this part of the book. Alright. Last was 9. Alright, then this one will be 10. Now, the number of notations. So first of all, I want to incorporate the during adiabatic expansion omega over t, over ts stays constant. This is one thing that I was going to use. We also recall that u is equal to at to the power of 4. This is one more thing that I'm going to use. And that pretty much is. Now, if for some reason all this radiation is at particular frequency, which is stupidity, and I will get out of this stupidity in like 2 minutes, but let me just make Courtney's statement, then constant times t to the 4 power is equal to omega to the 4 power. If I do 4 power of that thing, then you understand, since omega and t are proportional to each other, 4th power are proportional to each other. So therefore, right sides after division give us constant. This is u divided by omega to the power of 4 stays constant. Right? So during adiabatic expression, as we expand, temperature drops, u drops. Yay? Yay. Now immediately let me improve. Instead for saying what I just said, which is kind of not what we deal with, right? We don't deal with one particular frequency. We actually want to study how this distribution function looks like. Then I can say, all right, so let's look at omega and omega plus d omega. See, we're expanding from one single point to a segment and to entire partition from 0 frequencies to infinite frequencies. Is everybody comfortable here? So if I watch all these frequencies, this whole band, narrow band of frequencies, left boundary will change, right boundary will change. No surprise, but question.
So the scenario we're looking at is all of our radiation is in omega to omega plus d omega strip?
No, not anymore. Originally I said, oh, what if there is only one frequency? And then I made fun of myself saying, who does that? And said, no, now I'll go back to entire distribution. But in this entire distribution, I selected regions from omega to omega plus d omega and paid attention to that particular interval. But because this interval is arbitrary on an entire axis from 0 to infinity, I didn't make any sacrifice of generality. It is as good as it could possibly be. I don't know what I just said, but something good, right? Is everybody happy? You guys are in a good shape time-wise, so don't hesitate to ask a trillion of questions. I was ready that we're done there, so if it would be done only there, I would be already happy, but we still have 20-something, 7 minutes or something, which makes me happy. I can go slowly and clearly. Good? Amazing. So if we're in this interval, then entire energy sitting in this interval will be u sub omega d omega divided by omega to the 4 power. That's that was tragic or it was good? No tragedy happened. Okay, good. Yay?
What is that quantity?
It's what we started with, u sub omega, spectral energy density. Yep, times d omega, which is du. So du is u, sub omega d omega. This is not my notation. You guys know I don't invent notations. I teach you conventional notations. Maybe if I'm in charge of notations, I will not call u thing that is joule per cubic meters and also joule per cubic meters and 1/2 Omega is measured in radians per second, right? So this u and this u have different units, but they both are u's. That's notation. Question?
Can you quickly, sorry.
I can slowly go ahead.
Explain
Ask.
why we can do this with the u omega d omega? Because previously it was like the whole u over omega to the 4th is a to the 4th is constant, but a tiny section u omega d omega du, is that like you don't like why can you still say that's t to the 4th as well?
Yeah, entire distribution should be t to the 4 because if not, there will be answer function of t. If there are regions that contribute t squared, regions contribute t cubed, regions contribute something else, after integrations you will get polynomial. So the only dependence of u of t is t to the 4 in every single segment. Also, yeah, I would say I would stop here. Now, during expansion, omega transforms in omega prime, and omega plus d omega transforms into omega plus d omega prime, right? I mean, it's trivial statement. When it expands, old omega became new, and right boundary also became new. But we know that over expansion, omega divided by t stays the same. I wish I wrote it with bigger distance from each other. Yeah, whatever, I'll need to write it again then. Omega over t is equal to omega prime over t prime, as well as omega plus d omega over t is equal to omega prime plus d omega prime over t prime. Is it super duper clear? I wish I didn't erase the previous graph. Let me maybe repeat it. So if you have, I don't remember colors, but I think initial was yellow. If you get this initial distribution with these omegas, and then after a little expansion, omegas reduced, right? So this right boundary moved here, this left boundary moved here. So this is omega prime, and this is omega. This is omega plus d omega, and this is omega prime plus d omega prime. Do you guys see what happened? Bent, traveled. left boundary of the bands traveled, right boundary of the bands traveled. What I will say now, I will not surprise anybody. You might even say, why did you spend that much time? But if I subtract this equation minus this equation, left sides, help.
D
T omega over T.
Awesome.
Is equal to D omega over T.
You might tell me, isn't it clear itself? Maybe yes, but I kind of want you to picture this in your head. Old, new. And so boundaries moved. Both. Overall width, because omega is proportional to t, I mean, it's pretty trivial that d omega is also proportional to t. I still wrote it that way. Any questions? Look at the board. If there is something that causes any kind of discomfort, then I will erase right side of the board, hoping that you keep thinking. Whatever. I will keep this right. All right. Yes.
What is this transformation we're doing, like physically? We're just saying consider changing the temperature, or?
Yeah, adiabatic change. I consider adiabatic change.
And so when
Why I consider adiabatic change? Because I want to explore. Let me tell you what I'm doing. I want to explore U sub omega. Let me put here goal. Explore U sub omega as a function of omega and t. That's the goal. Makes sense, right?
Right.
So therefore, in order to explore a function, I should shake parameters, right? What is safe way to shake parameters? If I adiabatically transform, that shakes the graph. But I know from thermodynamics, adiabatic transformation does not change entropy. So therefore, if I had equilibrium distribution before, I have equilibrium distribution after. That's the method what I use. Keep asking.
So omega and our omega prime, do they have? We're just saying like we're looking at a point and
Looking for what?
like never mind. Sorry.
Are you sure?
No.
Keep
I
asking.
also don't know my question yet.
Okay, keep making question. Any more questions? Any dissatisfaction with something? You know, if you are not sure, you need to engage in conversation. If you're not sure what to ask, but you're not happy, then engage in conversation. It will reveal. Is everybody happy? Yes.
To just clarify, U omega is like the energy density per omega, right?
Say it again?
U omega is.
Yeah. If I no, I didn't say yes. Yes, I got it. Now listen. So if I look at old left boundary of a segment of radiation I selected, then it will move to the new left boundary after expansion. And if I look at right boundary, it will also move to the new right boundary. This is what d omega prime is. Difference between right boundary and left boundary. Before and after, yes?
U omega, not
U omega. Because temperature changes, my new function U is new, function of entire omegas. So this is a red function is U as a function of omega. And this is also the same function of omega. But one is done for t, the other graph is done for t prime. Does that make sense? Keep asking.
So, in some sense, you could think of this transformation as say, I'm going to go from t to t prime, and then the graph transforms this way.
Perfect.
Okay.
That's what I was going to say. Thanks. Anybody else? It's really often something bothers you deeply, and then you find, oh, that's easy. Boom. That's what you need to do by asking trillion questions. Everybody's happy. Almost. Awesome. Thanks. Continue. Yeah, I didn't say here. Actually, I said, but I didn't write it. That this stays constant, right? And yeah, questions?
If that's a constant, and that's the thing you're integrating to infinity, why don't you just get infinity?
Why? No, constant is the whole combination. Oh, no, okay. It's not constant in, I don't know what to tell you, except for I will just write exactly what I wanted to say. Prime, d omega prime, that's what I was going to say, nothing more. Makes sense, right? So the energy in this column divided by omega to the power of 4 for this column is same combination for old column. That's all of what I wanted to say. Makes perfect sense. Not less than perfect. Awesome. Let me then solve this equation. Not solve, but use it to transform and get something. And I will be more specific about these arguments. Omega, oops, it is u as sub omega of omega and t is equal to, I moved all this stuff to the right side. Omega goes on top. Omega prime stays on the bottom. D omega prime stays on top. D omega comes to the bottom. And u prime of omega prime and t prime. Please check if you feel happy. Yes?
So why are we saying those two are equal under the transformation?
Yeah, because we, because energy is proportional to the fourth power, and omega is proportional to the fourth power. And you already asked me earlier, it cannot be like one region is to the fourth power, the other region is to the third power. So if overall integral is always t to the fourth power, then all temperature dependence could be only to the fourth power region by region as well. Make sense?
No. Like what you're saying makes sense, but I don't know why that means that there should be a variable.
If you look at energy, which is omega d omega, this, and if you agree that it is proportional to the t to the fourth power, and you understand that omega is also proportional to the t to the fourth power, then this ratio is the same. It holds. We good?
Yeah.
Keep asking. Next question.
Is that supposed to be a u prime sub omega?
Absolutely, because those guys are even have different units. Thank you so much. This is good catch. Awesome. Any more questions? Any more catches? Any typos? Any stupidities? Awesome. I'm doing a last transition before I make big statement. What is omega over omega prime? T over t prime. What if they are both to the fourth power? Huh? What? Awesome. What about d omega prime over d omega? what is omega prime? Omega prime is t prime times omega over t, and t prime is t prime, and I think I didn't miss anything. Yay. Right? Let's see. Finally, I can cancel t prime and make 3 here. I can also cancel t to the first power and make 3 here. And I got my final answer. U omega as a function of omega and t is equal to t cubed multiplied by u prime omega t prime omega over t prime divided by t prime cubed. Yes?
How is this a useful final answer?
Oh, because it's almost final. It's not yet final.
Okay.
Yeah, sorry for that. It does not look pretty. Yeah, let me criticize this final answer. So if you agree with all that. Now, what if I look right now at Blackbody at temperature T, particularly I'm staring at point at omega. I see certain value, right? Yay?
Yeah.
Awesome. What if I came to this temperature from T prime equals to whatever degrees? Or I came to that point from T prime equals to something else degrees. Would I get the same distribution if right now I have temperature T? Does it depend on prehistory? It cannot, yeah?
It's like adiabatic then.
Exactly, if it is adiabatic expansion, right? I can run movie other way around. I will start with T and I'll look at omega. And now I can change it from T to whatever values, multiple different values. Does my current function depend on that? So answer, this function does not depend on T prime. No matter what is T prime, it is the same. What does that mean? It means that U prime changes in such fashion that no matter what was T prime and this T prime, that function looks this same way. From here, I can make final statement. That my function should look that way. I will not explain anything new today. I will dance on this result, and if we have luxury of time, I might revisit equipartition theorem. Are we good? Yeah, we have 7 minutes. I need 2 minutes to dance and then 5 minutes to do equipartition. Is everybody happy? If everybody is happy, then congratulations, we got something beautiful. I could actually rewrite this in this way. Can I multiply this by omega cube and divide by omega cube? Then t cube over omega cube is also a function of omega over t, right? So therefore, if I divide this by omega cube and multiply it by omega cube, I can write it this way. Omega cube times some chi function of omega over t. Is it clear that these two are equivalent? Yay? Awesome. Now dancing. 11. What I will get right now should not surprise you, because we actually put it on input recently. But let me still check. What is u? U is integral of u sub omega d omega from 0 to infinity, right? Which means that I need to substitute that thing. This is t cubed integral from 0 to infinity phi of omega over t d omega. Can I divide this by t and multiply by t? Can I do u substitution, call omega over t c? Then what I get? I get t to the power of 4 times integral from 0 to infinity phi of c d c. This is universal function. The integral is a number. Moreover, we called this number earlier a. So now if I know phi function, I can calculate a. So my next lecture will start with finding phi function. And we will fail, because we'll see how this integral is diverging. Isn't that awesome? Because not only we will fail, the whole classical physics will fail. And that's a big deal. So get ready. By the way, I keep forgetting to tell you, I will email everybody. Next lecture is during 1 to 3 problem session. Because at 4 p.m., for these little babies, there will be Zoom open house. And I don't want to miss Zoom open house for prospective students. So those of you who cannot make it from 1 to 3, this guy will keep working, but this one.
Oh.
Yeah. And the lecture will be uploaded, maybe even before, no, before 3 I cannot upload it, pretty quickly. In any case, from 3 to 5 you have problem session 2. By 5 I'll do my best so it is uploaded. Make sense? So therefore, same room. I hate CCS room, but I'll teach there. And last time I taught there 9 years ago. I still remember how I hate that building. Yeah, but it's all right. Yeah. In each decade, I teach there once. It was 2013, so now it's 23. Awesome, 10 years. And see, I still remember. It was spring water. Yeah. Now we have 5 minutes to do something we did in CS33, and you most likely forgot about it because we have 5 minutes. Let me quickly redo it. You guys, is everybody comfortable with all that? Got it, right? When we will get Planck's law, it will also satisfy this pattern. Isn't that amazing? Yeah, it's amazing. Rayleigh gene satisfies this pattern, but it fails because this will be diverging function integral. All right, 12. E to the power of negative e over kt. We know what it is, right? It's Boltzmann's factor. All right. If energy is a function of variable xi, quadratic function, for example, is m over 2v squared quadratic? Awesome. Is k over 2 x squared quadratic? Is I over 2 omega squared quadratic? So most of energies that we know are quadratic. Not all of them. Is negative gm1 and 2 over r quadratic on r? No, so not all of them. So some energies are quadratic, most of them are quadratic, some of them are not. So what? Do we hate those? Not really. I mean, thanks to this energy that stars exist. Without sun, we will have no energy here, this light, whatever. Let me continue. All right. So therefore, the distribution function is e to the power of negative alpha beta c squared, where beta is 1 over kt, which is standard notation. We used it multiple times, and the whole world is using 1 over kt beta. All right. Then, how do we, first of all, how do we determine A? To determine A, you take integral from 0 to infinity, or if c could go from negative infinity to positive infinity, A e to the power of negative alpha beta c squared dc should be equal to 1. If you multiply this by radical alpha beta and this by radical alpha beta, I don't know what I just said. Let me write, you will see what I said. From negative infinity to positive infinity, e to the power of negative, any letter that is not badly involved in anything, x square, whatever. Yeah. And in order to write here dx, what should I do with c? Multiplied by radical alpha beta. If I multiply this by radical alpha beta, I should immediately divide by radical alpha beta and say that this is equal to 1. Everybody knows this integral, what it is equal to. Square root of pi. So a is equal to square root of pi alpha beta. Sounds good? And what is average value of E? Average value of E is equal to A, we know what A is, multiplied by integral from negative infinity to positive infinity, alpha c squared, e to the power of negative alpha beta, c squared, dc. Do you guys agree? Yeah.
Is A and the other one root alpha beta over pi?
Yeah, let me double check. A, this is 1. Oh, you're right. This is pi here. You are absolutely right. Thank you so much. Alpha beta over pi, because radical pi is also on left side. Question?
Don't we want to use, like, let's say it's e to the minus beta e dE, then you also have to transform the differential element when you go to dc, right?
If this is distribution in xi, then this is xi. Then you can do substitution of variables. Make sense? Gabriel?
No, because if you have expectation value of e is equal to this integral, e to the minus e dE, you should be able to plug in your e of c function, and it should give you the same thing.
Oh, I did. This is alpha c squared. Yeah, this is alpha c squared. Yeah, it's here.
No, but the differential should have an extra, like,
no.
dE equals 2xc alpha dxc.
No, in statistics, average of anything, average of A, is equal to integral from negative infinity to positive infinity, distribution of x, A of x dx, where integral from negative infinity to positive infinity f of x dx is 1.
Okay.
Make sense?
Yeah.
All right. So integral of x squared times this is radical pi over 2. So if you use that, you get that this is A, which is radical alpha beta over pi. This alpha out. This integral requires another xc, which is 1 over radical alpha beta. Right? Yeah? And this will be radical pi over 2. And I'm looking for beta. What happens to beta?
Don't you
Shouldn't
take
that-
derivatives?
Huh?
To solve the Gaussian integral, should we take derivatives with respect to alpha beta of root pi over alpha beta? So, maybe.
Root pi over alpha beta.
You have to get the.
Oh, I did not substitute here as well. So that one is also should be multiplied by alpha. Alpha is already here. I should multiply this by beta and divide by beta. Okay, now it is good. Yay? Got it? So what is the answer? Did you follow everything? I will be done in a second, then I will stay to answer all these questions. This is all gone. We got beta, 1 over 2 beta, which is kT divided by 2. Congratulations, we proved equipartition theorem. No matter what is nature of alpha, no matter what is nature of xi, if energy is quadratic, then average energy is necessarily kT over 2. That's the goal. Sorry, I stole 3 minutes of your priceless time.